Q3301. What force makes an airplane turn? A. The horizontal component of lift. B. The vertical component of lift. C. Centrifugal force. The correct answer is A. The force that makes an airplane turn is the horizontal component of the lift. When an airplane is in a turn, the wings generate lift in a direction perpendicular to the wingspan. This lift force can be resolved into two components: a vertical component that opposes gravity and supports the weight of the aircraft, and a horizontal component that acts inward toward the center of the turn. It is this horizontal component of lift that provides the centripetal force necessary to make the airplane turn. Centrifugal force, mentioned in option C, is not a force itself, but rather an apparent force experienced by objects in a rotating frame of reference. 3316. During an approach to a stall, an increased load factor will cause the airplane to A. Stall at a higher airspeed. B. Have a tendency to spin. C. Be more difficult to control. The correct answer is A. During an approach to a stall, an increased load factor will cause the airplane to stall at a higher airspeed. The load factor is the ratio of the lift force acting on the airplane to its weight. When the load factor increases, such as during a steep turn or a pull-up maneuver, the stall speed of the airplane also increases. This means that the airplane will need to be flying at a higher airspeed to maintain lift and avoid stalling. 3202-1. Select the 4 flight fundamentals involved in maneuvering an aircraft. A. Aircraft power, pitch, bank, and trim. B. Starting, taxiing, takeoff, and landing. C. Straight and level flight, turns, climbs, and descents. The correct answer is C. The 4 flight fundamentals involved in maneuvering an aircraft are straight and level flight, turns, climbs, and descents. Option C correctly identifies these fundamental maneuvers. Straight and level flight refers to maintaining a constant altitude and heading. Turns involve changing the aircraft's direction by banking. Climbs involve increasing the aircraft's altitude while maintaining airspeed. Descents involve decreasing the aircraft's altitude while maintaining airspeed. 3202-4. If an emergency situation requires a downwind landing, pilots should expect a faster A. Airspeed at touchdown, a longer ground roll, and better control throughout the landing roll. B. Ground speed at touchdown, a longer ground roll, and the likelihood of overshooting the desired touchdown point. C. Ground speed at touchdown, a shorter ground roll, and the likelihood of undershooting the desired touchdown point. The correct answer is B. If an emergency requires a downwind landing, pilots should expect a faster ground speed at touchdown, a longer ground roll, and the likelihood of overshooting the desired touchdown point. Option B correctly describes the effects of a downwind landing. Due to the tailwind, the ground speed of the aircraft will be higher than its indicated airspeed. This increased ground speed will result in a longer ground roll as the aircraft requires more distance to come to a stop. Additionally, the higher ground speed increases the risk of overshooting the desired touchdown point, as it may be more challenging to decelerate and control the aircraft in the available runway length. 3202-5. When executing an emergency approach to land in a single-engine airplane, it is important to maintain a constant glide speed because variations in glide speed A. Increase the chances of shock cooling the engine. B. Assure the proper descent angle is maintained until entering the flare. C. Nullify all attempts at accuracy in judgment of gliding distance and landing spot. The correct answer is C. When executing an emergency approach to land in a single-engine airplane, it is important to maintain a constant glide speed because variations in glide speed nullify all attempts at accuracy in judgment of gliding distance and landing spot. By maintaining a constant glide speed, the pilot can accurately judge the gliding distance and select an appropriate landing spot. Any significant variations in glide speed can make it challenging to accurately assess the distance covered during the glide and choose a suitable landing area.